Welcome, everyone. Thank you for joining us today for our technical talk. I think we have all different time zones from 4 o'clock to 7 o'clock on the East Coast. So thank you for joining in from wherever you are. My name is Ada Walsh, and I'm the VP of Dinner Meetings for the Philadelphia Chapter. Before we get started, just going to run through a couple of announcements and then some housekeeping, and then we'll do some introduction of our speakers, and then we'll get to the good stuff. So one announcement for the Philadelphia chapter, we got some response from some members that they were missing seeing everyone and missing having the social aspect of our dinner meetings. So be on the lookout for our December dinner meeting, which will be more of a social event, and we'll hopefully get to know some of the new officers. So be on the lookout for that. And then Connor from the VP of the Arizona chapter, I'm going to pass it over to you for announcements that you have.
Okay, great. Thank you very much. First of all, we just wanted to thank the Philly chapter, and Ada, you guys have been doing an awesome job, and we're all really excited for this chat, looking forward to it. I'm actually standing in for Colton right now. He is our program director, and he put in a ton of work to help make this happen. So a big shout out to him. He had something come up last minute, but he does a lot of legwork in the background and wanted to make sure he got the recognition for that. Also wanted to thank Gary Clinton for reaching out to and connecting with some of the speakers and helping to make this possible as well. For the Mesa chapter, our biggest event coming up is the 9th Biennial Autonomous VTOL and eVTOL technical meeting and symposium that's happening in January. So it's a national event with the chapter and this with the national chapter and international, excuse me, chapter. And this year it will be virtual because of COVID reasons. It is January 26th to the 28th. We have over 20 technical abstracts that have been submitted, and really looking forward to a fantastic event. We hope to see you guys all there. Thank you. Back to you.
Great, thanks, Connor. So before I introduce our speakers for tonight, if you have any questions during the presentation, please type them into the question box on your GoToWebinar screen, and then I will read those out to the speakers at the end. And with that, I will introduce our speakers. So Scott Janetsky is the Director of Flight Operations at Columbia Helicopters. He has been responsible for the activities of over 100 pilots, administrative staff, and cabin and crew members. Scott joined Columbia Helicopters in 1991 and served as command pilot, training manager, and chief pilot before assuming his current position. As a helicopter pilot for Columbia, Scott has logged over 10,000 flight hours in the company's tandem rotor aircraft. Missions have included heavy lift helicopter, water bucket and tank firefighting, external load logging, construction, and Part 135 passenger carriage. Scott's work has taken him to many parts of the world, including countries in North America, South America, Asia, and Australia. Working with the engineering team at Columbia Helicopters, Scott helped develop performance improvements in the 107 Vertoland, the first fire tank installation on a CH-47 Chinook. As a pilot examiner, Scott has licenses in both Europe and the US. He has issued over 100 aircraft type ratings to aspiring pilots in both the BV-107 and the BV-234 CH-47D. In his personal life, Scott lives in the Portland area with his 3 sons and an active golden retriever named Sadie. Next, we have Robert Roedts. He is the Senior Director of Aviation Technology and Manufacturing, responsible for directing Columbia Helicopters engineering, manufacturing, and supply chain organizations. Prior to joining Columbia Helicopters in 2010, he had multiple engineering positions at GE Aviation, Pratt & Whitney, In Situ, and Lifeport. Rob graduated from Penn State's Vertical Lift Center of Excellence with a Master of Science degree in Aerospace Engineering. He holds a Bachelor of Science in Aerospace Engineering and Mathematics from Virginia Tech. He is also a licensed glider, helicopter, and drone pilot. Next, we have Keith Saylor. who earned his commercial pilot and flight instructor ratings from Sacramento Executive Helicopters in 1994. He worked there for 3 years as a flight instructor prior to joining Columbia Helicopters. Keith joined Columbia in 1997 as a 107 and 234 co-pilot on various projects, including logging, firefighting, construction, and oil field support. Keith became a 107 command pilot in 2000 and a 234 command pilot in 2006. During his time at Columbia, he has worked throughout the United States, Indonesia, Papua New Guinea, and Mexico. Keith enjoys all aspects of Columbia's helicopters operations. He developed a preference for heavy helicopter firefighting operations and subsequently specialized his skills and knowledge in this area. In early 2008, Keith accepted the position of a fire operations manager, which includes market development and oversight of Columbia's U.S. and foreign firefighting operations. In 2014, Keith was promoted to Director of Commercial Operations. Keith is responsible for Columbia's Oil and Gas Division, Firefighting Division, Construction Division, Logging, and Stream Enhancement Divisions. We did have a fourth speaker planned, Cody Barton, who is the Chief Pilot at Columbia. Unfortunately, he had higher priority tasks as a pilot this evening and won't be joining us. Before I hand it over, I just wanted to give out a couple of things. First and foremost, to Columbia Helicopters and all of your speakers for taking time out of your day to speak with us. We're all very excited to learn more about Columbia Helicopters and the work that you do. I'd also like to thank Olivia Wolfgram, Columbia's Business Development and Marketing Manager, who worked closely with me in organizing all of the logistics and planning all of this out, as well as Santiago Crespo, who's the VP of Growth and Strategy, who I spoke to originally about getting y'all to come talk. So thank you to everyone at Columbia, as well as Jim at VFS for organizing all of the GoToWebinar stuff. That's really helpful, and so hopefully this will all go smoothly. And I think that's all I have. So without further ado, I'll hand it over to Scott. I think you're going to be presenting first.
I believe so, yes. Okay. Well, I drew the short straw, so I get to speak on behalf of Columbia Helicopters and our team. Rob developed this slide deck here last year for a symposium we had about the same topic, basically the challenges around firefighting and the innovations that are coming about through the industry. Little side notes, Keith and I, we fly a desk more than anything else. In fact, that desk that's right behind that bookshelf that's right behind Keith right now. We fly a lot, but we actually go out and fight fire on a regular basis still. Last year, we brought a Chinook down to Southern California. At the same time the campfire was going on in Chico, we were flying right past there on the way to a fire in Southern California. That's an interesting story we may talk about a little bit later, where we had to turn around because of heavy smoke. And then Rob and I have been together on some developmental performance enhancements on the 107, as well as modifying the military CH-47Ds to make them useful for firefighting and external load work. So anyway, here's the slide deck in front of us. It's the firefighting and the challenges that surround it, specifically what we've seen over the years at Columbia Helicopters. Next slide, please. All right, hopefully we'll get through this in about a half an hour or less. I'll talk real fast so that won't leave any time for questions. Actually, as I'm speaking, if you think of things you want to talk about, put them in the chat box, and then we'll try to get through them at the very end of this. And I think we'll have plenty of time for open flowing discussion. The first thing we have on here is, of course, the introductions. And then we'll get on to the Columbia Helicopters, a little bit of the history behind our company and the aircraft that we operate. Then one of the things that came about through the years and that our founder, Wes LaMotta, innovated was they call DVOC, Direct Visual Operational Control. And we'll talk about that a little bit further into the presentation. And then firefighting, right? The reason we're all here. The fire dynamics. One of the biggest challenges is flight and reduced visibility. whether it's smoke or whether it's just flat nighttime, right? And then the last thing, the future of firefighting and our open discussion. Next slide. All right, Columbia Helicopters is based in Aurora, Oregon, just south of the Portland area. It was found by Wes LaMotta, a Oregon native, in 1957. It's based out of, again, of course, Aurora, Oregon, and that's where I live and Rob lives. And Keith lives remote down in Phoenix, Arizona. Our current operating fleet is 13 107s, 10 234 Chinooks, and 3 CH-47Ds. 9 of the 107s are in Afghanistan. 2 of them are in the United States. They were both fighting fires this summer. Our 234 Chinooks, which is a civilian variant of the Chinook, actually the middle one in that picture on to the right, is we have 3 of them in Afghanistan flying troops there, both external loads and troops and cargo internally. And then we have 1 in Australia, getting ready to fight the fire season this year. They did quite a bit of firefighting last year, and as you recall, it was a pretty bad fire season there last year. We have 1 in Papua New Guinea that was just coming off of an oil contract. We are in the midst of sending 1 down via boat down to Chile for their firefighting season, and then we have 1 left here in the United States, and it's actually being worked on potentially to send down to Chile for the second contract. We have we purchased 11 CH-47Ds from the military years ago, I think in 2016, and we're operating 3 of them. It gives us a massive part supply and support package for the 3 operating aircraft. 2 of them are tanked and 1 of them has a long line. Okay, moving on to the next slide, please. What do we do as a company? Obviously over there on the right, you see some, they're putting together what looks like a ski tower as part of the infrastructure support that we do, as well as construction, whether it's putting air conditioner units on tops of buildings or power lines or anything like that. Keith Saylor is the Director of Commercial Operations, and that's his business unit specifically. Overseas, in 1974, we started helping with the assembly and disassembly of oil rigs in the jungle of Papua New Guinea, and we continue to do that to this day. Actually, as everybody knows, the oil market's on the downturn. The price per barrel is pretty cheap. Not a lot of oil exploration this year, but doesn't mean there won't be a resurgence of it in the future. We've been working in Ecuador, Peru, again, Papua New Guinea, and a lot of jungle territory. I worked there personally for 2 years. Next thing on here is forestry and stream work. Columbia really cut their teeth with long line work, doing heavy helicopter logging, and that's where we introduced what we'll talk about next is flying loads with a relatively long line, right, 200 feet or longer. And then the next segue into that would be, or the next natural step into that is stream work, which is basically building fish habitats and putting logs back into the rivers so they build good pools for the salmon and fish. Firefighting is what we're here to talk about. We've been doing that since the late 1960s and still do it to this day. In 2016, we got into the tank world so we could have a little better urban interface, and but our bread and butter has always been external load with the water bucket. And then about 9 years ago, we got into the Part 135 world. We had a 135 certificate since the 1970s, but we sent a number of aircraft over to Afghanistan in support of the war effort over there. And currently we have 12 aircraft over there, nine VTOLs and 3 Chinooks. Okay, next slide, please. The early years, Columbia Helicopters and Wes LaMotta got started in 1957. Like any startup company, Wes was doing whatever he could to make a buck with an aircraft, right? He started off with a Hiller 12B, and he was doing flight instruction, scenic tours around Mount St. Helens, and you can see over there on the right, he was actually doing an aerial trapeze show. Whatever he could do to basically make a buck. In late 1957, a barge started sinking off the coast of Oregon in Astoria, and you can see that over the top right there, him attempting to rescue, or he did not attempt it, he did rescue 15 sailors off that aircraft and shuttle them back and forth to land one at a time, with somebody actually leaning out off the skid and pulling him on board the aircraft. And that got him quite a bit of notoriety, and the company started to take off. The next year, they actually purchased another aircraft to do more flight instruction with. As you know, in the Northwest, logging itself is a really big endeavor, and they typically will log trees off the sides of mountains with either a skidder or a tower logging. Looks like something you'll see at the circus, where a line goes down the hillside and they attach logs to it and then drag them up the hillside. All right. Well, Westland and Jack Erickson both partnered together to figure out if they could do that via a helicopter. And in 1962, they purchased the first S-58 helicopter that we had, and they attempted to do just that. They attempted to log with a helicopter. Wes's brother actually was the first guinea pig to do that. They took the door off the side of the helicopter, and he leaned out to look at the load on the ground. All right, and it actually became quite successful. And Jack Erickson then took that operational concept with him back to Erickson, started that company, as well as Wes began to grow the company that way. And in 1967, they purchased an S-61, got rid of I actually think we still owned the S-58 at that time. They purchased 61 to do that. And then they also decided that wasn't really advantageous to do it without a bubble door. It felt like more like Ace Ventura. So we developed the bubble window so you could fly faster than 40 knots. Next slide, please. All right. In 1969, Pan Am out of New York was getting rid of their 107s and actually replacing them with S-61s. And Columbia Helicopters purchased 3 of them. They subsequently purchased a number more from Pan Am before they went out of business themselves. And then we started replacing the 61s we had here at Columbia with the 107s. 107s have a distinct advantage, I believe, and it's obviously a little bit jaundice or a personal view of that, in that they don't have a tail rotor that gives up part of their lift for creating lift. All your horsepower goes to vertical lift, and you can actually create quite a bit of lift just by pedal input. That's getting off topic here. A couple years after that, we got into the oil field, as I said earlier, with 2 107s. We sent them to Papua New Guinea, and we've been there ever since. Later on, and I'm not sure what year this is, we introduced 234s to the oil market as well. In fact, they now build oil rigs around the 234. In 1984, we purchased 2 234s from British Airways. They had been using them for passenger transport in the North Sea, and they got away from that operation. These were long-range 234s capable of carrying 44 passengers. Obviously, they used most of their payload, or most of their weight was fuel and fuel tanks. So when we're doing short distances and trying to maximize the amount that the helicopter would lift, we needed a new variant of the helicopter. So in 1986, Columbia and Boeing partnered together to create the UT version of the aircraft. Over those next couple of years, between 86 and 2006, Columbia continued to purchase all of the 234s that were on the market. The last 3 were purchased in 2016, which is the last line item on here. to include 2 that were previously owned by Donald Trump. He'd been using them to shuttle gamblers between his casino in Atlantic City and in New York. And in fact, that's when I came on Columbia Helicopters, had a big black T or golden black T on the back of the helicopter. In 2006, Columbia acquires the 107 and 234 type certificates from Boeing. And in 2009, we actually got the production certificate for both aircraft for parts only. In 2014, the military decided they were going with the Echo model and the Fox model of the CH-47D. So they were getting rid of the surplus 47D and allowing civilian operators to purchase them. Like I said, that Columbia purchased 11 over a number of years, and we started flying the first 2 back to the Oregon area from Alabama in 2014. During that same year, 2014, we started modifying the aircraft for use on firefighting. We did a number of modifications to the aircraft to include removal of the requirement of a 3rd crew member. You know, that was a military requirement, basically to help load passengers in the back, help shoot down bad guys, help when they are going to do parachuting operations, and a lot of things that didn't have to do with what we were going to use the helicopters for. And the 234 didn't require a 3rd crew member, so we were able to rewrite some of the emergency procedures and normal procedures and get rid of that requirement, as well as remove the ramp off the back. That way we could maximize load. And then, of course, the last thing was to add a bubble window to the aircraft. And then we issued the restricted type certificate, which includes that ramp removal, 3rd crew member removal, and the bubbles on there as part of the TC. And then I don't see on here, maybe we talk about it a little bit later, the tank STC, which we introduced to the 47D. In 2016, I just mentioned this a little while ago, we purchased the last 3 aircraft from the Taiwan government, making it a total of 14 234s that were manufactured, and Columbia owns them all now. Okay, next slide, please. All right, going through the different aircraft that Columbia operates. This is the one we purchased back in 1962, and it's still the bread and butter of our fleet today. And Keith and I imagine have a special love for this aircraft, having flown it thousands and thousands of hours. It's got a max gross weight of 22,000 pounds. The aircraft itself weighs about 11,000 pounds empty, and then of course you add fuel and a couple of fatty pilots in there, and your useful load is around anywhere between 9,000 and 10,000 pounds at the end of fuel cycle. Beginning of fuel cycle, quite a bit less, right? About 8,000 pounds. Each engine's capable of producing 1,500 shaft horsepower, 1 engine inoperative, that is, and about 1,375 under takeoff conditions. Due to the bubble window installation, we limit the helicopter to 120 knots. The VNE can actually be a little bit higher. And it's not shown here with this aircraft, but there are extended range fuel tanks we've added to the aircraft. We have them in all of our aircraft in Afghanistan, as well as one of them here. And it adds another 85 gallons per side to the aircraft, and it'll give you a 300 nautical mile range and a total fuel capacity of about 550 gallons. All right, next slide, please. For you engineers who are doing math there, it's about 165 gallons an hour. The 234. The 234 is capable of 51,000 pounds max gross. The aircraft itself weighs about 24 and a half or so. And so the useful load is around 26 to 27 at the end of fuel cycle. It drinks up quite a bit more fuel than the 107, about 400 gallons an hour. 4,700 shaft horsepower per engine, a lot of horsies there. Again, we limit the VNE to 120 knots because of the bubble window installation. There's 2 variants of the helicopter. The long range version, which is shown there on the top, and that 242 was actually one of the Trump-owned aircraft years ago, and it was painted black at the time. And you can see it's shown there. I think that's actually over Afghanistan. It's in Afghanistan currently, and it's got 2 1,000 gallon fuel tanks on it. It's got a pretty healthy range on it, 500 nautical miles, longer than my bladder. And then the UT version, which is the one there on the bottom, 239, that's the aircraft that's on its way down to Chile right now. It's got two 500-gallon internal tanks. You can see that we removed the external tanks, helps reduce the drag, and actually helps with the performance. So you can get a little bit more performance-wise out of that aircraft than you can out of the LR. A much shorter range, 240 nautical miles, and you can see that 1,000 gallons. All right, moving on to the next slide. The 4070, which is very similar to the 234 LR, and in fact, when you get a type certificate, you're actually qualified for both aircraft as a pilot. Has a slightly lower maximum gross weight of 50,000 pounds. The aircraft is capable of lifting 26,000 pounds, slightly less in its operating weight, around 24,000 pounds. Slightly more in the horsepower that those engines will produce, 5,069 shaft horsepower. We got the VNE up a little bit on those bubble windows to 130 knots, and it's got much better fuel consumption rate based on a FADEC that those engines have, and it's around 310 gallons an hour or so, giving us a much better range of 300 nautical miles with what is basically UT fuel amount, 1,000 gallons. Okay, moving on to the next one, please. All right, we talked about this in the beginning, the DVOC, Direct Visual Operational Control. So the first thing we did in I think it was 1962, was remove the door, and Jim Lamotta was flying with his head out the window to control the load by basically looking at it rather than having somebody in the back telling which way to position the helicopter. The military does that pretty extensively. Being a military guy myself, you have somebody in the back telling you left, right, up, down, and it's as you know, you're probably driving with your eyes closed. It's not very efficient, and somebody telling you what to do. So the hard part is actually learning how to do it, and everybody get used to seeing a horizon, sitting up, and how to manipulate the helicopter. When you're looking down, you remove all that peripheral vision, and it's quite interesting training somebody new to how to apply that method. It's like learning to hover all over again. So Jack Erickson and Wes Lamotta refined that technique in the early 1960s, and then they added a bubble window to the 61. And then, like I said, Jack Erickson took that technology with him over to start up Erickson. In 1979, Wes Lamotta received the Captain William Costler Award, American Helicopter Society. And I'm not sure what that is, to tell you the truth. That Rob wrote that. If he wants to chime in, he can. Otherwise, we'll talk about it later. And now all of our aircraft have it. Every aircraft has a bubble window. Is our preferred method of flying, and it gets you out of a jam pretty easily compared to flying. So if you can imagine yourself in bad weather when the ceilings are starting to push you down, it's real easy to lean out the window, see the ground, see the trees, and basically fly a lot slower and lower to get yourself out of harm's way. Okay, moving on to next slide, please. In 1966, while working next to fire logging, fires broke out, and they needed us to reposition the aircraft and begin firefighting. And we repurposed two 200-gallon concrete buckets that basically had a flapper valve on the bottom, had a cable going up to the cockpit, and you would dip this concrete bucket into a lake, fill it up to its brim, and then bring it over the fire and pull on this cable, and the full contents would drop on the fire. It's fairly light compared to what the helicopter capacity is for the 61. So you can see the second picture down there. The Oregon Department of Forestry approved use of two buckets together. The next, obviously, wasn't very efficient, and over the years we improved the process and how we could draw water and put it on fires. And so I inserted this next date here for the Griffith bucket, and I'm not really sure when the 80s we got the Griffith bucket, but they are a polyurethane bucket, a very moldable, not moldable, but they're soft-sided, but they're not completely collapsible. And they were 1,300 gallons for the 107s and 2,600 gallons for the 234, which is basically the size of a hot tub. And they have a gate in the bottom that's electrically controlled by the pilot on his left-hand collective. And he can open the gate and close the gate. You will lower the bucket into the water and allow it to fill in from the bottom. Or if you submerge it all the way down, obviously it'll fill in from the top. And once you get to the quantity you want, you close the gate with the coolie hat on the collective and start coming out of the water. In addition to this, we have a strain gauge on the hook beam that will tell the weight of the load. And so as you burn off fuel, you can obviously take on more water. So you can let water out until you have that premium amount of weight ratio for the helicopter. And then when you get over the fire, you can make numerous drops just by opening and closing that gate. And you can make numerous drops or one big long drop. That worked for a lot of years, and I used them, and Keith used them on numerous fires, Griffith buckets. But in the 90s, late 90s, we introduced Bambi buckets, which is a collapsible bucket we could put in the back of the aircraft. Very efficient. You couldn't get the 2,600 gallon bucket in the 234 in the back of the aircraft. The thing was just simply too big. You could do that with the 234. We do it with a winch system, but you can get in the back of the aircraft. And in addition to the Bambi bucket itself, which had the same contents, we also put in a power fill system. Actually, we didn't do it. The Bambi company did it. They have 4 high-speed pumps capable of drawing water down to 18 inches. And so that really allowed us to go into places such as streams, shallow rivers, small ponds, and that kind of thing, and suck up water into a bucket. We've done that probably more times than just simply filling a bucket. And it really helps with the efficiency on fires. You don't have to fly miles and miles to a deep water source. You can get it out of a very close river or stream. And especially when you combine that with a 150-foot long line, you can see that you could be really effective lowering it down through the timber, drawing up water, and then fighting the fire that's within a couple hundred feet of where you are. In 2015, really due to industry demands, they've been using tanks with the sky cranes for years for urban interface, and it seemed like that was the way of the industry. They really wanted fire tanks for urban interface and fighting fires, places like downtown Los Angeles. So we, with those aircraft that we purchased, we started designing one and implemented it in the 47D. That tank, which I think is highlighted on the next slide, we move to that. Blink. It was deployed in 2016. As I said, Rob and I went through the testing of that aircraft, and in fact, that picture is taken in not over fire. That picture is taken during its development in the Willamette in outside of Portland area while we're testing the tank. It was partnered with the Simplex company here in the Portland area as well to develop that tank and all its telemetry unit and everything else that goes along with it. It's got a 2,800 gallon capacity and a 140 gallon reservoir for fire retardant. And we use both of those things pretty extensively. This last year we were on call. We need to stay busy on the entire fire season. As you know, it was a pretty robust fire season. And the 3 years prior to that, we've been, actually 4 years prior to that, we've been fighting fires on contract with the Forest Service. It is designed to fill a tank within 60 seconds. It has a 9-foot snorkel that is 10-inch diameter. You can see it hanging off the left-hand side of the aircraft. The pilot can lean out the bubble and reference the snorkel. We'll either stick it in a reservoir or a dip tank. either place. And we've done quite a bit of dip tank operations. They love the putting retardant on fires. And then it is capable of various water coverage levels. So you have both a manual and an auto mode, and you can will open the gate on the tank various different levels. And I think we have a video to show you about the operation of the fire tank. You want to click on that?
You know, every day we're there on shift to make sure these things stay flying and don't have any maintenance interruption during the course of the business day. And then at night, it's go, go, go until we get this thing up and ready to fly the next morning by the beginning of business.
Given the addition of our 47Ds to the fleet, our existing 234s, and the amount of capacity that these aircraft have, there's a huge opportunity for us to, actually put a fire tank in these. And actually put a fire tank in that will perform better than any deployed system that's out there right now for aircraft. And these aircraft, I'll tell you, are just absolutely amazing what you're capable of doing with these. And for the power that you get and the amount of capability, the reliability as well is way above what you would think you'd get for an aircraft this large. It's actually amazing how reliable, how dependable these aircraft are.
We are focused on meeting the needs of the customer. We go above and beyond what our competitors do because we want to be prepared. We want to set the pace. We want to be available for the Forest Service or whoever the customer is.
Whenever you see the snorkel dangling below the aircraft, there's a pump at the end of it, and it's powered by a hydraulic pump. And that actually sucks the water up into the tank. So it pumps it up inside, and there's a backflow valve to keep the water from flowing back out of it, because it actually fills from the bottom up. Once you're done pumping, you take off, fly to wherever you want to dump the water. And whenever you go to dump it, there's doors that are right inside the existing external load hook, and that dumps the water out. And all the water dumps out. A full tank will dump in 3 seconds, so it's 2,800 gallons is all dumped out.
This helicopter is the largest civil helicopter available for firefighting. It can deliver the biggest payload of water to a fire. We can either do it with a water bucket or we can do it with an internal tank. Columbia has pioneered the first internal water tank for the CH-47D, and with the idea that we can have an urban interface as well as a rural area with the water bucket.
This system is the way things are going with this industry, and I think right now with this model we're ahead of the power curve with that. And this is an awesome machine that we're going to see well into the future working on fires and supporting the U.S. Forest Service and hopefully other agencies abroad.
At the end of the day, the biggest thing that we always concentrate on is satisfying the customer. And this is why, it's great having the relationships that we do, because it gives us an opportunity to really have that conversation and see what can we do better. And the great thing about Columbia is that we will do things to make it better.
All right, I think I'm unmuted. Can you guys hear me okay still?
Yes, we
All
can.
right. Nodding head, yes. All right, so move on to the next slide here. I know that's a little bit of a self-love video there, but there are other operators that have developed tanks, and they are getting in the industry as well, doing the same thing. It's really a big industry demand now, that firefighting with a tank, and we're seeing more and more ask for that type of operation. In fact, we still have one of the aircraft still on contract down in Southern California, fighting fire down there. And last year we actually fought fire right up to Christmas Day with our tank, the aircraft. Which is Keith's business unit. He's going to take over the lead.
Thanks, Scott. Good evening, everyone. Before we get into the slide, I'd like to give you guys a bit of background on the business end of it and how it relates to different agencies. So throughout the United States, there's stakeholders that, for lack of better words, landowners that agencies own. They have, for example, U.S. Forest Service has their land, BLM has theirs, Bureau of Indian Affairs, and as such, they got together as a group and decided to create in Boise, Idaho, NIFC, which is the National Interagency Fire Center. Through that, they work as a team to protect their lands throughout the United States. And to a lesser extent, assist with states that have their own personal land that they try to protect. Within the United States, it's broken down into 10 regions, very similar to what we call GACs, Geographical Area Coordination Centers, that are, to some extent, a lesser entity that relies on NIFC to support them when they break a fire. NIFC also does a lot of analyzing, does a lot of guesstimation. They've gotten pretty good over the years. They deal with drought conditions, weather, temperature, relative humidity, the different fuel classifications, whether it's 1 hour fuel, 10-hour fuels, 1,000-hour fuels, topography in the areas, and they, of course, take all this knowledge and information and establish red flag warning areas, and pretty much try to predict and prepare for where fires are going to be in the United States at any one time. They have preparedness levels throughout the United States, both nationally and throughout the individual regions. They're set at 1 through 5, with 5 being the highest. The highest extreme fire conditions typically indicate there's a lack of resources to respond in that area, where 1 is low fire danger and many resources just in case they have to respond. They're after preparation and anticipation, they're fairly reactionary. So as a fire starts, and I think as a kid I remember Smokey the Bear telling us that only we can prevent forest fires. Well, unfortunately that's not the case. 70% of fires are started by lightning. Only 30% approximately is started by humans, whether that's accidental or intentional. As everybody probably knows, get a fire going, you got to have a few things. There's a 3-sided triangle there that depicts what needs to be, and of course the ignition source is the big thing. As a fire begins, the incident command system takes into effect. They start putting resources on the fire. Typically, it's the ground pounders first to respond. Sometimes it's aerial assets alone, but more than likely it's the ground pounders. They use their normal tactics in which to fight fire, which is anchor and flank, try to pinch a fire off at the head. As they arrive on the scene and establish the anchor point, it's called initial attack. It's the first burn period, which is the first day. If it goes past that, it's considered extended attack. And as we we affectionately call it a project fire as it grows bigger and bigger. The tactics in which they fight the fire, there's two basic tactics. It's fighting the fire on the fire line itself. As the ground pounders call it, 1 foot in the black. And the other way to fight the fire is in the green. This is probably the most dangerous portion of firefighting, as everybody likes to stay very close to the black because it's been burnt once and very unlikely that the fire will roll through again. When you're out in the green, that's typically when fire can get a head of steam, get rolling, and move at 30, 40 knots of speed. As the ground pounders employ their tactics, and it's all predicated on, of course, weather, the situation, its topography. They'll call in aerial assets to assist them. That's where we come in. There's a team management structure that runs the fire itself, utilizing air assets and ground troops, and the mixture of the two truly is what assists in putting the fire out. I know that a lot of people think that the area assets do a lot of the fire extinguishing, but the truth of the matter is ground pounders, we assist by cooling the fire, whether that's with suppressants or retardants. There's if you wanted to start the video, I believe there's a video here.
Wildfires are uncontrolled fires that spread quickly and can destroy homes and the environment nearby. But how do these fires start? And how do they spread and become dangerous so quickly? It all starts with a spark. Lots of things can cause a spark, such as a burning ember that blows away from a campfire, lightning, heat from the sun, or often, human error. In fact, most wildfires in the US are sparked by human activities. If a spark happens in the presence of oxygen and fuel, such as dry grass, brush, or trees, a fire can start. And conditions in the weather and environment can cause the fire to spread quickly. Fires need a lot of fuel to grow. Unfortunately, overgrown forests and thick vegetation can fuel a fire to grow out of control. The weather can also make a fire worse. For example, drought, winds, and extreme heat can make a fire bigger, faster, and more dangerous. But before taking action, firefighters need to understand where a fire is and how exactly these environmental and weather conditions will affect the fire. With a view from high above Earth, weather satellites, such as NOAA's GOES satellites, can provide information to help firefighters and the rest of us stay safe. With their special vision, weather satellites like GOES can detect fire and smoke and see the heat of very small fires before they are spotted on the ground. Meteorologists also use data from GOES satellites to give firefighters an up-to-the-minute forecast of changing wildfire conditions. Smoke from a fire can cause poor visibility for the helicopters and airplanes that are used to fight fires. It could also cause bad air quality, which is unhealthy for the people who live and work nearby. GOES satellites monitor this smoke and can help firefighters determine when it will be safe to fly and when it's safe for anyone to spend time outside. Wildfires can be really scary. Thankfully, GOES satellites are always up there keeping an eye on things to try and help us stay safe. Find out more about Earth weather at NOAA SciGinx.
I'm not sure whether there was any volume with that or not. I didn't hear anything on my end, but as we look at what it was depicting, there's a lot of input from different areas. There's different teams that are employed by the incident command system. There's teams 1 through 4. Type 1 team is your largest team that runs a fire. They're dedicated to the bigger fires or complexes, as they're called. They employ up to 40 people that move and travel with the team. Everyone from finance to logistics, human resources. It's fairly extensive, and these are your top firefighting strategists that employ modeling, computer modeling, to anticipate with topography, the area, the drought conditions, the known fuels and down fuels in the area, can estimate and determine how to fight the fire using natural breaks or man-made breaks. And these teams really do lead the fight. There's briefings in the morning where they line out the priorities and how they're going to fight the fire. These briefings in the morning are for the ground crews, the hotshot crews, the jumpers, engine crews, and also for the aircraft overhead, whether it be fixed wing or helicopters. And hopefully they're successful in anticipating winds and all the other aspects of the weather conditions in which to fight the fire. There are definitely some challenges with fighting fire when it comes to visibility. We found in the past that at its most pure usefulness is basically 2 human beings and a radio. And many times fighting fire, and I'm sure Scott can champion this, is that the ground pounder that's needing the assistance, between him, his radio, and the pilot, they can talk back and forth and place the water where he needs it for whatever he needs. As this is jeopardized by smoke and other situations, whether it be night firefighting as well, it becomes more and more difficult. And that's some of the things that we're going to be looking for in the next slides, and of course in the future, to increase the efficiency of what we do and how we do it. Next slide. Highly active area during operations. There's a lot going on a fire. The biggest part of the burn period during the day is from 2 to 6 p.m. That's not to say it can't be active earlier or into the night, but typically that's when you'll notice that the most activity is ongoing with aerial assets as well as the ground pounders. Firefighting aircraft can be fixed wing or rotary wing. They're separated by an air attack who coordinates and orchestrates the use of the aerial assets as the ground crews need help. There's also observation aircraft as well in many different forms. The ground coordination is part of the team that coordinates with the air asset and the helco or air attack to ensure that they're getting what they need and interacting properly. It's quite at times can be a high-speed ballet and works out well typically. We work very close with the people on the ground as well as other aircraft. There's typically a dip site for what we're using helicopters with. dip sites can have a daisy chain associated with them, where there'll be multiple aircraft dipping at the same spot, and placing that suppressant on the fire at the same spot as well. There's methods to keep coordination between agencies may differ a bit, but in actuality, it's pretty common. So whether you're working with the U.S. Forest Service or BLM, the tactics are typically very close with a bit of nuances here and there. I know that the evolution of being a green pilot on a fire and understanding what's really going on and eventually becoming part of it as a command pilot was enlightening, to the point that it isn't haphazardly. There is a thought process in the way fires are fought, and as we like to say that we tip our hats to the ground firefighters. They actually are the ones that put it out. We just assist. And with that, I think we'll go to the next slide, and I'll turn it back over to Scott.
Yeah,
Okay,
so
Rob, you want to talk to this next section?
Yeah, absolutely. So, we've, in the last couple slides here, we've been talking about where we've come, how we traditionally fight fires. I would say that between Scott and Keith, in terms of fighting fire with aircraft, if those two don't know it, probably nobody else does. But really where we're in here today is to start talking about what are we looking for the future. A lot of things have changed, a lot of new technologies in place. But the first and foremost, a big focus for a lot of different operators and agencies is how do you fly and reduce visibility. It just so happens that about the clearest time of the day, which is between 2 and 6, is actually the worst time to fight fires because they're most active. They tend to calm down at night. You have humidity build up, a bunch of other things that will mitigate the fire. But right now, there's not a lot of ways to actually see what's going on, and that's because of that smoke and also nighttime. And then also the winds die down quite a bit during the night as well, and there's not as many ground crew on the ground either. So industry has been looking at different ways you can do it. Probably the biggest thing that's been out in the news that if you follow this at all has been night vision systems, night vision goggles, that sort of stuff. Columbia actually is a night vision goggle. We have OpSpec to be able to do it in our aircraft. We have a couple aircraft with the systems installed. Some people are looking at it. We've had some discussions, but we're thinking that it needs to be a much more comprehensive method. There might be some limited use of night vision goggles, but there needs to be other things. And there's been some looking at whether it's synthetic vision, whether it's LiDAR, whether it's advanced avionics, such as flat panel or HUD systems. There's ways that we can do it to increase that situational awareness for the pilots and the operating crews. But there's been a couple tests done with limited success, but we do see that there's going to be more and more focus on this as it goes ahead. I think it's Keith, it's California and Australia that have really been pushing for this in the last couple of years, I think. Is that correct? California, Australia?
They have.
Yeah. But we're trying to see what is the best mix, and what is the best tool to, first and foremost, ensure that you're effective whenever you're doing this, but even more important than that is the safety of our crews whenever you're doing these operations. There's a lot of chaotic situations, and you don't want to put somebody in harm's way when they don't need to be. Next slide. So ultimately, it turns into the future of firefighting. There's a lot of stuff coming to the market right now, and honestly, from Columbia's perspective, it's all about how do we use this in the best way possible. There's new technologies, as you can see on the right-hand side there. Probably the biggest thing right now is UAS, unmanned aerial systems. Problem though is that there's no clear role. What do you do with them? Do they drop water? Are they observation? What's going on? Not to mention, there's been a lot of issues with unmanned aircraft fighting fires. In fact, you probably see some things, if anybody follows the FAA or any sort of notices from CAL FIRE or anything like that, they have a huge issue with drone, interactions and drones getting in the way of fighting fires. Whenever you fight a fire, there's usually a temporary flight restriction that gets put in place, which means that nothing's supposed to be going up. If aircraft see drones flying around, that means that they can't fight fire. And and whenever you want to deploy them, what are you going to do with them? There has been some interest from the Department of Interior. We've talked with them multiple times. They've also talked with other folks, but we're still just trying to figure out what is the best way to employ those. Another thing that's gets overlooked is that there's no new aircraft models being introduced into the space right now. Utility helicopters, if you take a market survey, in the commercial sense, a lot of the aircraft are legacy aircraft. There's nothing on the books. There might be some limited employment of, like, say, a EC225. Problem though is, for the newer aircraft, the operating cost is way too high to actually make it feasible to fight fires with them, which is why you see surplus Blackhawks, surplus Chinooks, some legacy commercial aircraft like the Sky Crane or the VTOL still being employed here, and there's nothing to replace it. So you don't see anything really coming out to market right now other than UAVs, and like I said before, there's no clear there's no clear role for those aircraft. And then ultimately, wildfire activity is growing globally. We're seeing this all over the place. In fact, we've gotten into a dance last couple of years where we've got aircraft coming off fires here in the US, and they're going immediately down to Chile, or they're going to Australia, or they're going to any number of places, and it looks like that this is going to, continue. There's not a ton of resources out there. I mean, for the aircraft deployed, yes, they're being used and used well, but with the growing fire activity, we're trying to see how can we best at Columbia place our resources, while still making it feasible to be able to do this work. So it's a huge challenge ahead of us, and we're looking at this stuff actively, talking with some partners to see what we can do to work out. But ultimately, as we see here, there's no clear, solution to fixing the issues that we have. There's been, and as Keith did a great job of articulating this, there's a very well-defined system on how we fight fires in the US, and honestly, a lot of places around the world. It's just that with some of this new technology, it's very difficult because night vision goggles and night vision systems have their, their limitations. UAVs right now don't really have a clear role. There's a lot of technology that's just not very clear about employing it. So, as we look forward here, we're still trying to find it, and ultimately, that's where we're working with people around the industry to see what we can do. Next slide. All right. There's a couple pictures of us, but ultimately that's the end of the slideshow. At this point, we did want to, of course, leave plenty of time for questions and kind of discuss a little bit, but hopefully that gave you guys a good overview of who we are, and then also, more importantly, firefighting and how that works in the country, especially with the amount of press it's had.
I'd like to tie in with a couple of things, or add on to a couple of things that Keith said and that Rob said, and kind of foot stomp some of the things. So, as you know, the Forest Service has a lot of aerial assets they use every summer. In fact, I think they have, or they promoted as having, the largest air force of all contractors, right? Comprised of contractors, and in the world, and that we all play under the same set of instructions, essentially, right? And it works out quite well. So on a large project fire, you may have as many as 9 or 10 Type 1 helicopters, which are the large helicopters, and we all work like a fire brigade. We're in a daisy chain, going to the same spot and going to the same area, and dropping the load, and then they call tag and extend. You put your water where, basically at the end where the last guy dropped his water, and continuing on. And you can see that there's just this big aerial show going on of overhead aircraft telling you where to go, guys on the ground, directing where they want the loads, and then of course the aerial helicopters themselves. On the ground, back at the helibase, you have every helicopter has its own manager. There's basically an ATC, they call the ABRO, Aviation Base Radio Operator. There's incident commanders. There's, like I said, there's Air Attack and HELCO, which is the helicopter coordinator. A lot of aerial a lot of oversight in order to keep all these operators working under the same page. And so now you start adding NVG to that, right? All of a sudden, those guys, you need twice the shift, right? So my vision is I can see you can start adding on to the day, right? So rather than at 7 o'clock when it's starting to get dark, you start, or now you just flip the goggles down and you continue to fight fire under NVGs and tacking on to the end of the day. Those kinds of things versus trying to go out there at 2 o'clock in the morning when there aren't those guys on the ground. Additionally, we're talking to some of the Forest Service guys when they're trying to do it down the Los Angeles areas, is that you may be able to fight fire under NVGs, but you outrun the guys on the ground. Them navigating on the ground over uneven terrain, they can't keep up with the helicopter. And like Keith had illustrated that we're about half as effective. They can't then turn that wet soil over, much like you would kick out a campfire, right? Not only to put water on it, but then you also turn the soil over to keep the fire from re-erupting, right? Myself, I was on fires here in the Oregon area for a couple weeks this summer. 2 weeks on the fire, I flew 6.7 hours. And the reason we flew 6.7 hours is because of heavy smoke. So the bad thing about it is you want the winds to carry the smoke out and allow you to fight fire, but they also make the fire bigger, right? So when after the fire gets good and going, the winds die down and then you're sitting on the ground. So that is, to me, is one of the biggest challenges, is being able to fight fire and reduce visibility. All right, with that, we're opening for questions.
All right, awesome. So I've got a couple questions came through the chat box, so I'll just go through those. Let's see, starting with one from Andy Keith. What is the difference between the 234 and the CH-47, or are they mostly the same?
So if that question was for me, the 234 and the 47D are essentially the same. One's a military version, one's a civilian version. They each have their own little idiosyncrasies. But from a standpoint of piloting, I think that they're very close to being able to fight fire, very close in the performance. I think that the UT versus the 47D, the 47D has a little bit farther endurance, and it's got a little better lifting capacity at certain altitudes and temperature. So if you're talking to a 234 pilot versus a 47D pilot, I think the 47D pilot is going to tell you his aircraft's just a little better.
Yeah, they're both very similar in performance for sure. Definitely we're talking a late 80s aircraft versus a 90s aircraft, and there's a lot more technology in the 47D versus a 234. It definitely takes a lot of thought to fly the 234. But their performance is very, very similar. Probably the biggest difference, honestly, is that the 234 was developed under Part 29, meaning that you can send it in a standard category helicopter. You can actually fly passengers in it, and you can send it overseas, right? The 47D is a restricted category aircraft. It was built under for the military, and very difficult to send overseas, high TAR restrictions, as well as it can't be used for passenger carriage, and you have to have a special exemption to fly it in congested areas.
Interesting. Okay, great. Thank you, and thanks, Andy, for the question. Next, we had a comment actually from Scott Janetsky. You mentioned the Captain William J. Kostler USCG Award. That's from the American Helicopter Society, which is now Vertical Flight Society. So he has the quick description, so I figured I would read it. It was established in 1951, given for the greatest achievement in the practical application or operation of vertical flight aircraft, the value of which has been demonstrated by actual service during the preceding year. The award honors the memory of a U.S. Coast Guard airman, aeronautical engineer, and early advocate of helicopters in search and rescue operations. So.
Holy moly.
Seems like y'all were very well deserving of that award.
I'm
guess you wrote
sorry.
that down for a reason.
Yeah, I'll take the blame for that, Scott. I should have briefed you on that. The certificate's actually in my office, so I should have given you a brief of what it was. My bad.
It seems relatively prestigious.
Yes, it is.
Let's see. So next we have one from Brian Touchman. How do you determine whether it's better to use a bucket or a water tank to put the fire out? I was wondering this as well.
All right, Keith, you can answer that one.
Yeah.
So just like any good toolbox, you'd like to have multiple tools in there, and truly is having a bucket versus a tank at different times advantageous. So when you're out in the wilderness, the bucketed aircraft have a tendency to penetrate the trees better to get the water to the ground. Unfortunately, anything hanging underneath the helicopter has an opportunity to come off that helicopter. So therefore, urban interface, the tanked aircraft are typically used there more often than a bucket. So it really is a specific tool for this specific job.
Great. Okay.
Yeah, I think that's really driven by the customer more than anything else. Because of that perception that you will lose the load, and there have been loads lost over the years on firefighting, right? And I think I recall there one being lost on an UH-1 years and years ago. We have never lost a load in Columbia helicopters with a bucket, knock on wood, right? And I personally have a love for buckets because you can go into places, you can draw water, like I said, out of a stream or river, where a tanked aircraft requires you to have a very large footprint in where you're going to draw water from. Thinking about all that brush and debris you could ingest into the rotor system when you're within 15 feet of the ground. Having said that, it's got a great place in the urban interface, and you can fly a lot lower. You can get under a column of smoke closer to the ground, where you have to be potentially you're gonna have to swing that bucket in underneath a column of smoke in order to get to the fire's edge.
Great. Thank you. Let's see. Did have another comment from Scott Janetsky. Well, I guess it is a question. He is the Operations Committee Chairman for VFS, and he is wondering if you would consider writing a paper or and presentation for the 2022 Vertical Flight Society Forum.
Let me answer that for Scott. Yes, he will.
So I will say I did submit a history of helicopter firefighting to the history committee as a primary and operations as the secondary. So if the history doesn't want it, it is up for 2021. So we'll let the history committee and the ops committee fight over it.
There you go. Great. That's awesome. Let's see. Okay, so I have another one from John Mordosky. Does Columbia perform its own engine maintenance, repair, and overhaul activities? Oh, there's a couple of questions. Are there any licensing agreements with Honeywell or the U.S. Army for engine spare parts? Are spare parts available for the AL 5512 engine on the 234, considering the limited number of 712 series engines operating around the world?
Okay, I'll take that.
I think
He's also the director of supply chain, by the way, so this is right in his wheelhouse.
Yeah, exactly, unfortunately. But Columbia is the sole licensed service center by Honeywell for the T55 engine in the world. So we do our own engine maintenance. We work with Honeywell routinely on things and have a very good relationship with them. So we do maintenance on all of the T55 series, including AL 5512, of course, which is on the 234. Spare parts, we source them from Honeywell and other places. And then we also do maintenance on the 712 version of the T55, 714A, and that includes both the L and GA models. So we're, for T55 models, we've been maintaining those since we got the 234s in the 80s. and have had a very good relationship with, for those who remember, Avco Lake Cumming, from them all the way through the various different areas that the engine span between Allied Signal, Honeywell, and the other places it's been. So yeah, to answer your question, yes, we do all of that.
Great, thanks. Here's a quicker, probably easier one, maybe. What outside air temperature levels do you experience in the vicinity of fires? That's from Dave Woodley.
Yeah, we don't really notice any increase in temperature around the fires or increase in turbulence. All right. Obviously, if you're getting downwind of the smoke, you'll get smoke in your eyes and on your flight suit and everything else. But I don't see a noticeable difference at all in the temperature. Like Keith said, much like they have 1 foot in the black, that's usually where we're dropping the water. We're dropping on the edge of the fire. It's almost useless dropping water in the black or an area that's already been burned, or right in the middle of a fire where it's really not going to do any good, right? It's usually on the edge of the fire where it's there's not a temperature difference.
Gotcha. Yeah, that makes sense. This is from Scott Janetsky. Do you use a mapping tool like the one developed by ATI in Australia?
You want to answer that, any? No.
Yeah. So the government agencies do have mapping tools. That's usually by a smaller aircraft that sets that up, and at night they'll map the whole fire area. And they'll put those maps out during the day for us to know where the division breaks are and how it's progressed. But they are mapping those fires daily.
Let's see. Got quite a few more questions. We have, I think, about 10 more minutes. So what kind of impacts on the aircraft do you see flying through smoke so often, and what design changes have been made to address them? That's from Timothy Russell.
So the only thing we do is a daily engine wash that's required, and you can obviously get degraded performance from repeatedly flying through the fires. But there's no additional maintenance required on the aircraft, nor do you see any kind of degraded maintenance. You obviously have to clean the bubbles every day. You ash on them, but
yeah. One thing I will add to that though is that what you end up doing with firefighting is that you do have multiple load cycles and power applications on the aircraft. We have made multiple structural improvements to the Chinook in particular to pick up on that. We actually learned this through logging, and that's transferred over to firefighting as well. So we've actually done quite a bit of structural improvement to the aircraft to pick up all those load cycles that go into it.
Great. Thank you. Sorry, I'm trying to make sure I don't skip any ones. Do you guys have approvals to do your own FAA maintenance? From Gary Clinton.
Yeah, thanks, Gary. Yeah, so we have a FAA approved repair station at our main facility in Aurora. And what we do through there is all of our own maintenance. So we send very little out of house. We have our own, we do full transmission overhauls on all the transmissions, flight controls. We do full overhauls on those. Blade maintenance, rotor heads. We actually do all of the rotor heads for the Army Chinook fleet. They actually go through our facility for those. And then also with that, to complement it to our maintenance, we actually, since we own the tech certificates, we have our own engineering staff as well. So we'll do repairs, design improvements, everything else is all done in-house. So yeah, we have a fairly large capability, MRO capability for our customers, both internal to Columbia and then also external. Yep. And and if anybody follows Vertical Magazine, I think that we actually have a ad campaign going on right now of all the things we can do. If you follow that, probably seen that last day or two, actually.
Great. Next one is from John Piasecki. What is the most common fault or component failure that you see?
I don't know, Keith, you get all the phone calls.
It's a gambit of
it comes in waves, right?
It does. We had, like any new product deployment, there's things that come up. There was a couple design cycles on the fire tank that we had to work through. We've actually spent a lot of time and effort to address those. I'm trying to think, Keith, like what's been, like I said,
I would suggest not so much a component, but we have had structural issues that seems to be constant. Well, when I say constant, that happen every so often. Down for sheet metal repairs. So I would say that's the most that stands out in my mind.
Yeah, and what we've done, and I think I mentioned this a little bit earlier, we actually built a FEA model of the Chinook to full scale model. So we actually went through the whole thing and modeled it up in FEMAP and been running NASTRAN, models for the last, gosh, we started this in 2013 and we've been running it ever since. And that's FAA approved as well, that we use that. And we've managed to mitigate a lot of the structural issues that we had in initial deployment with some of these aircraft to fix them and make sure that we don't have the issues that we did in the past, at least.
Lots of questions. Let's see. All right, so this is from one of our board members, Steve LeBeaus. Great stuff you guys are doing. Having flown the H-46 and H-47 in my military career, this was a treat. Looks like a pretty high usage rate with your varied missions. What kind of hours do you have on the airframes, and what kind of maintenance hours per flight hour do you see? Also, what kind of avionics package do you have for situational awareness and to facilitate coordination of the firefighting dance?
Different questions right in that, right?
Yeah. So,
there are a couple.
Yeah, so it depends on what missions we're doing. Firefighting, what, Keith? Scott, we do what, about 400 or 500 hours a year doing firefighting per aircraft?
Correct.
Approximately that, yeah.
Yeah, so, but then for our aircraft in Afghanistan, we do like 1,500 to 2,000 hours a year. So we can do a significant amount of hours per aircraft per year as we go forward here. Maintenance hours per flight hour, it's a good question. The way we set up our maintenance program, we actually don't do phase maintenance on the aircraft. We do continuous maintenance. So what we'll do per night is that there will be, I'd say probably a couple hours worth of maintenance. So I would say probably total, we're probably right about, probably below one for one, I would say, for the amount of hours we put in. But that of course gets changed if we're doing a B check or a C check, in which case the aircraft will be down for a week to do maintenance with multiple people. Trying to think what else he asked in there. The hours.
He's asking about
that one. It's a pretty basic avionics package at this point. We don't have
avionics,
situation awareness. Honestly, GPS and VHF radios and FM radios for communication.
Yeah.
A lot of. Go ahead.
Oh, go ahead. Go ahead.
No. And the only thing we have other than that is EFBs in the cockpit for documenting production and that kind of thing, as well as more than anything else. We incorporated ADSB here last year, and that's really where, in fact, we're going to probably be adding ADSB in. I saw that firsthand last year in a flight and reduced visibility. The advantages of that, right? Just being able to communicate with each other and knowing who each other are in the air, and just telling them I'm at your 2 o'clock 2 miles, that kind of information, and that will be displayed on our EFB rather than a heads-up display. Okay, Rob, anything to add to it?
No, you got it.
All right. I think we have time for one more question. Let me pick. This is one from Chrysanthi Camus. Does the team lose radio connectivity with the ground team asking for assistance rarely or frequently?
Actually, the ground communications are fairly decent. If you can imagine, there's 20 hotshot members to a crew, and they all radioed up. So if one of their radios has an issue, typically there's others on the crew that you can talk to and keep that communication open. Very seldom do we have anything in the aircraft that goes bad on us. And we've got multiple radios as redundant systems.
And honestly, very rarely will Air Attack ask you to go out and freelance, right? Put out fires of opportunity. You're almost always working with a ground person, and the ground person is moving and the fire is moving. So very rarely will you come back and drop water in the same spot every time, right? You'll have a general idea where they are, and as you get closer, you'll spot them and they'll tell you where to drop the fire. A lot of ongoing communication.
Great, thank you. Okay, well, there were a few more unanswered questions, but I want to be respectful of everyone's time. I know we've taken an hour and a half of everyone's time. Thank you all again for spending some time with us this evening. And that was a great presentation, learned a lot. I think everyone really enjoyed it. So again, I'd like to thank Jim and also Chris at VFS for working on all of the IT stuff, getting this webinar working. Hopefully everyone was able to hear everything the whole time and see the presentation. And thank you to Scott, Keith, and Rob for taking time to speak with us and share your experiences. Did y'all have anything else you wanted to talk about or say?
No, thanks for spending your time with us and giving up your dinner.
We'll go off to dinner now. But no, just definitely really appreciate the time. Columbia's been a corporate member of VFS for a couple of years now, and definitely enjoy getting more and more great with the community, and always happy to kind of talk about what we're doing actually with the aircraft and trying to show everybody how we can make them better. So definitely appreciate the time today.
Thank you. Jim at VFS, do we need to do anything else before closing out?
No, ma'am. We are all set. We just want to extend our thanks and appreciation for you guys putting this together, and to Ada for doing a great job moderating. So, Grant, I'll give you a round of applause on my end. Well done.
Great. Awesome. Thank you. And to all of our members, thank you for spending your evening with us or afternoon, wherever you are. And we'll hope to see you at future VFS events.
Thanks, everyone.
All right,
thank you, everybody.
Yeah.
Bye.
Good night, everyone.